In today's lesson, I will discuss the inverse of functions. And in this lesson, you will be able to learn how to define inverses, identify the misconceptions in the inverse notation, and be able to generate the inverse of a function or relation when it is given to you in a table. So I want you to look at this graph and write down the three things that you notice about it. So as you are thinking, I want you to look at the attributes of the blue functions with respect to the red dotted lines. So pause the video and write down three things that you notice about this graph. So the inverse of a function is defined as the reflection across the line y equals to x. So the key word here is reflection across the line y equals to x. So whenever you are given a relation or a function, the reflection of that relation or function across the line y equals to x is the inverse of that relation or a function. The domain and the range will be switched. That is, the domain will become the range and the range will become the domain. Also, the x values will become the y values and the y values will become the x values. The inverse notation is denoted by f to the power of negative 1x. Normally, we don't say it like that. So if I just say the inverse of a function f of x, I will just write it as, when you are reading this, you just say the inverse of f of x. Because of the way that this notation is written, especially because of the power of negative 1, there are misconceptions about inverses. So some students normally think that inverse is the opposite. No, it is not. Inverse is the reflection, okay? The reflection. Again, the key word here is reflection of the function across the line y equals to x. So the line y equals to x is the mirror that is reflecting that function. Also, because of the way the f of negative to the 1 of x is written, because normally if I give you x to the power of negative 1, okay, that means 1 over x. Because of that, it is also easy to think that the inverse of a function is a reciprocal. No, it is not a reciprocal. So you cannot say f of negative 1 of x equals to 1 over f of x. So this will be very, very wrong. It is not equals to, okay? So this is not equal. So please avoid these two misconceptions. Looking at the function that I gave to you before, you can see that this is the mirror, which is the line y equals to x, okay? And this function is definitely a reflection of this, and that is why y-intercept of this becomes the x-intercept in the reflection. And you can also see that the domain are switched, and the range is also switched. So how do we generate inverse in a table? So when you are given a table of a relation or a function, all you need to do is just to switch the x and the y. So you just switch the x and the y and you are done. So you draw another table. All the value of the x, now you put them on the new y. So this will be negative 2, negative 1, 0, 1, 2. So another mistake is student changing the negative to positive and positive to negative. Please do not do that. So, and the old y now becomes the new x. So we just write 7, 4, 3, 4, 7. And that's it. So the inverse of this table is this. So the question also asks us that, are the original table and this new and the inverse, are they functions? So definitely when we are talking about functions, we want to look at the x values. If the x values repeat, it won't be a function. So none of the x values in our original function repeat. So this is definitely a function. Okay. And when you look at the inverse, we have 7 repeating and we have 4 repeating. So this is not a function. So I want you to use this question to practice. and tell me your answers in the comments. Thank you so much, and please remember to subscribe.